Here we go. Already time for the Unit 3 test. So here is our Unit 3 test review. Looks like we have 5 pages here. Each video is going to be its own page. Fourth page, that's just going to be there. Sorry, the second page. It's just going to be the unit circles. So nothing new there. We've talked about that plenty, but it is very important here. So first things first, let's just go from degrees to radians and radians to degrees. Remember, a radian is just another way to measure an angle, right? So we have degrees, 0 to 360 is a full spin. And then when we talk about radians, 2 pi is a full spin. So our conversion here is 180 degrees equals 2 pi radians. Right? So 2 pi, 2 times pi, is going to get you all the way around a circle. So how do we convert from one to the other? All right, so basically we have 195 degrees. All right, we need to multiply that by pi over 180 degrees. Right, so the degrees cancel just like any other unit, and we're just going to have 195 pi over 180. Now, the last step here is to reduce that fraction. All right, I don't know what that is. So on your calculator, you just do 195 divided by 180. And then it's going to get us some decimal. Now, anytime you have, a fraction that you can reduce, just press math, enter, enter. It's going to turn that decimal into that reduced fraction here. So it's 13/12. All right, so this equals 13 pi over 12. Right? Another way to make fractions, you press alpha, the green button, and then y equals the very top left button. You see this top one, it's n/d, that's numerator, denominator. Right, just go 195 on top, 180 on bottom. Press enter, and it'll get you the same thing, 13/12. So that's how you can reduce your fractions here. Now, first one is go from degrees to radians. This one, we're going to go backwards. So we're going to go from radians to degrees. Now, notice how anytime you have a radian, you're generally going to have that pi in there. Well, we want the pi's to cancel. So since the pi is on top here, let's put it on the bottom. So we have 180 degrees over pi radians. Now the pi's are going to cancel. So you have 23 times 180 on top. I have no idea what that is. That's going to give you 4,140. All over 15. Your pi's knock each other out, so the pi's are gone. And now that's a fraction you can reduce. It's probably going to be a whole number. 4140 divided by 15 gives us 276. This is a 276 degree angle. There you go. Now, draw each in standard position and name the reference angle. Reference angles need to be in radians. All right, so 13 pi over 10. So just come to recap. We're going to start with 0, and then 1/2 of a rotation is just 1 pi. All right, 2 full rotation, or 2 half rotations, or 1 full rotation is 2 pi. All right, so up top, we're going to have pi over 2, and then downstairs, we're going to have 3 pi over 2. So now these radians, if you're good with your fractions, they should come naturally. Now, if you think about it, 13 pi over 10, that's bigger than 1, right? That's 1 3/10. So we know our angle is going to be somewhere down in Q3. It's a little bit more than 1 pi. So this is 13 pi over 10, right? It's not 1.5, so that's why it's in quadrant 3. It's not 15 pi over 10, it's 13 pi. So now the reference angle just has to get us back to 1 pi. All right, and what is that reference angle going to be? That reference angle, remember, reference angles are always positive. So the reference angle here is 3 pi over 10. All right, now the next one, -7 pi over 20. It's a negative, so it has to go clockwise. Now, if you think half of a rotation would be 10 pi over 20. All right, so this one doesn't quite get to halfway. So that is going to end up in quadrant 4 here. This is -7 pi over 20 over 20 All right. So the reference angle just gets us back to the x-axis, and in this one, it's just going to be a positive 7 pi over 20. And now the next one is 11 pi over 18. So if you think half of that is going to be 9 pi over 18. So this does go past the halfway point. All right. So how much past the halfway point? Not too much. All right. See, I made a mistake. That's wrong. All right. So up top here, let me kind of recap. This up here is pi over 2. Right? So that's half of a full pi. A full pi is 18ths. So if we think about this, if we get that common denominator here, this is going to be 9 pi over 18. All right, but we're at 11 pi over 18, so it goes a little bit up here. This gives us 11 pi over 18. All right, and if we want to think about the reference angle gets us back to the x-axis. All right, we're going from 11 pi to 18 to 18 pi over 18. So if you really wanted to, math it out here, you got to think 11 pi plus what gives us 18 pi over 18. Right? And the answer there, that didn't really work out. The answer there is going to be 7, right? So this is 7 pi over 18. And so that is our reference angle. Now they want us to name the complement and supplement of each. So, all right, you got to think we need the complement gets us to 90 degrees. All right, so think pi over 2 is kind of our 90-degree angle. So we're trying to get halfway to 30. So you got to think, okay, what is half of 30? So the complement, you got to think 11 pi over 30 plus what gets us to 15 pi over 30. Right? And the answer to that one, of course, is going to be 4 pi over 30. All right, now, anytime you have a fraction you can reduce, you should reduce it. So this one turns into 2 pi over 15. All right, so that's your complement. The supplement now, you got to think 11 pi over 30 plus what gets you to 1 full pi. But again, we're looking at common denominators here, so I'm going to call this 30 pi over 30. And you got to think, all right, 11 plus what gets us to 30? And this one is going to be 19. So 19 pi over 30 is our supplement. So let's say we'll say complements are in blue, supplements are purple. All right, and let's do it one more time. All right, so 11 pi over 20 plus something gets us 10 pi over 20. It's got to get us halfway to a whole thing. So what is that going to be? That is negative 1 pi over 20. Let's do it again now with the supplement. So the supplement, 11 pi over 20 plus something gets us to a full pi, but a full pi is 20 pi over 20. We're kind of unreducing the fractions here. And the answer to this one is going to be a 9 pi over 20. So there's our complement and our supplement. Right? Name a larger and smaller coterminal angle. So to figure out coterminal angles in degrees, we added 360 and then we subtracted 360, right? That got us the bigger one and the smaller one. So what we have to do here, all right, if we are looking for the coterminal angles for radians, we're going to have to take our starting angle, so our 15 pi over 13, and to figure out the bigger one, we're going to add 2 pi. All right, and to figure out the smaller one, you just need to subtract 2 pi. All right, so if we just kind of split this up, we're going to say 15 pi over 13 plus, so instead of saying 2 pi, right, I can call this 2 pi over 1, get that common denominator here because we are adding fractions. Let's go ahead and call that 26 pi over 13. So that gives us 41 pi over 13. All right. Now to figure out the smaller one, just do the same thing. All right, we're going to have 15 pi over 13, right? That's kind of the one we started with, but this time we want to subtract 26 pi over 13. Right, so on this section, these degrees and radians, it's a lot of common denominators here. So that's going to give us, oh, what does that give us? I think it's going to be 9, negative 9. Negative 9 pi over 13. Should do it. 15. Yeah. No, that's not right. Hang on. 15 minus 26. It's negative 11. Negative 11 pi over 13. All right. There we go. So now question number 9 just puts it all together here. So first things first, they want us to convert this into degrees. All right. So we got 17 pi over 24. We're just going to multiply this by 180 over pi. Um, 17 times 180. And then we have to divide it by 24. And that's all right. That's going to give us a 127.5 degree angle. Right, which that's fine. It happens. We have that decimal for an angle, so not a big deal. Right? What quadrant is that in? Well, 127.5 degree. It's over here. So you could think of this as 127.5. They do want us to keep it in radians, though. So how about, let's fix that. We got 17 pi over 24. All right. What quadrant is that? Well, of course, that is quadrant 2. They want the reference angle. So the reference angle, it's going to be this one. All right. So what's going to get us to a full pi? So you think 17 pi over 24 plus what gets us to 180 degrees, or in this case, 1 full pi. So 24 pi over 24. All right. So 17 plus what is 24? That's going to be 7. So this is 7 pi over 24. Seven pi over 24. Now, luckily, just coincidentally, this doesn't always happen. This also happens to be the supplement. So you get 7 pi over 24. All right, so we kind of get 2 for 1 on that one. Now, a larger coterminal angle. All right, so 17 pi over 24 plus or minus 2 pi. So if we want to find the bigger one, add it. So 17 pi over 24 plus, now it's 2 pi. So 2 pi over 1 turns into 48 pi over 2. All right, that's going to give you 58, 65. 65 pi over 2. All right, and then to figure out the smaller one, subtract it 17 pi over 24 minus 48 pi over 2. What is that going to give you? That's 30, negative 31. Right? And the last thing we need is the complement here. So the complement needs to get us to half of that. So let's see here. 17 pi over 24 plus what gives us pi over 2. Right, remember, pi over 2 is that halfway point, this angle right here. This angle right here is, what is that? Pi over 2. So we're pretty much thinking, all right, what is that angle going to give us? So I'm going to get a common denominator here, and we're going to say 17 pi over 24 plus what gives us 12 pi over 24. All right, you got to think, all right, 17 minus what gives you 12. That's negative 5 pi over 24. Right? And that is going to be our complement. Negative 5 pi over 24. Right? And there we have it. That is page 1. That was all about degrees to radians, radians to degrees, and so on and so forth. Sorry, that one kind of got a little long, but it is what it is. All right, so we'll see you guys in the next one.